Welcome everybody to our Thursday seminar. Today we have with us Professor Alexander Burinskii. He is a member of the Theoretical Physics Laboratory of the Russian Academy of Sciences. He has been working in the versus direction related with the Kerr-Newman solution to charge spinning particles and black holes. For the last decade, he has been interested in the problem of the source of the Kerr-Newman solution and in the non-stationary generalization of the Kerr-Schild solutions for black holes and its connection to quantum theory. He has also been a collaborator with Roy Kerr in the early 90s about the Kerr theorem and non-stationary solutions. The talk of today will mainly address the work of not only the source of Kerr-Newman black holes, but also the changes in the exterior spacetime due to the electromagnetic excitations of black holes in exact form of the Einstein-Maxwell equations. And with no further delay, I leave you with Professor Burinskii. Thank you very much for being here.
I forgot to put in the paper is simply that this talk is also, and the invitation is also due to the fact that Professor Burinskii became the first award of the Gravity Research Foundation of this year, which is given every year, and well, there are a lot of researchers that send their works there to be awarded. And unexpectedly, because we have worked in this area and it's difficult that sometimes to be understood, we know it from the referees, but fortunately there is a good scientific board there and you receive the first prize. Okay, that's all.
Oh, first of all, let me thank Professor Manchado for very kind invitation. Yes, I have here. Okay, for invitation. And second remark that my English is rather bad, so I'm sorry for that. And because of that, sometimes maybe I will ask Sergey to comment or improve me. So sorry once more. So I am started about this work. It is mainly dedicated to exact solutions in gravity. However, it was mentioned exact solutions related with Kerr-Schild and related variants. But how it's mentioned by Hoft, that recent ideas and methods in the black hole physics are based on complex analyticity and conformal field theory, which unifies the black hole physics with superstring theory and physics of elementary particle. So I will speak mainly about Kerr-Newman solution, which is the most fundamental solution which describes not only rotating black holes and compact astrophysical objects, but also it paid attention as Kerr spinning particle. In this case, very fast rotation, and there is no horizon. The horizon disappears for parameter of rotation. A is, for parameter of rotation. Parameter of rotation A much more than M, the horizon simply more than M, the horizon disappears, and it is interest as Kerr spinning particle. So I really Kerr solution is heavily based on twistors. So because of that, twistors is used by mathematicians as very complicated theory, so it is not attractive for physicists usually. However, it has very simple physical meaning, and because of that, I would like to explain appearance on the very simple case of plane waves in general relativity. The usual plane waves is fixed by momentum, and nothing more because it is front of the plane wave is homogeneous. However, in plane waves in gravity, drastically differs because plane waves usual is carry infinite energy, and because of that it carry with the space-times, very strong back reaction, and really what is analog of plane wave in the case of gravity? It is so-called PP waves, plane parallel waves. By the way, they are very well described in Kerr-Schild form. So let's clarify a little bit this situation. So if we have front of plane wave, there is series of fronts, and wave is propagated with some momentum p mu in this direction. So really analog of gravitation pp wave is so that there is no absolutely flat front. In some sense, in some place there appears singularity, and this singularity will propagate together its front. As a result, the analog of plane wave in gravity is pp wave, but pp wave have singular line. Singular line. It is one of the versions. There are another versions of plane waves, but asymptotically flat gravitation flat wave is connects singularity on some line. It is null line, which is characterized by this vector of propagation p mu, but besides this, it has some position x mu. So we have that it is not enough in case of gravity. It is not enough to use only one parameter for plane gravitation wave. Necessary one more parameter, which is pointed on the position of the singularity, is motion in time. This singularity is propagated with speed of light if it's light-like wave, and because of that, one sees that there is in fact necessary couple parameters, and such couple parameters, in fact, very simply, it is twistor. It is coordinate and p mu. You see that there is mixing of coordinate and moment of reflection. So wave plus a trajectory of some beams. So with plane wave in gravity is related some kind of beam. Because of that, I will speak about beam-like solutions. Such beam-like solutions appears in gravity too, in particular by excitation of Kerr black hole. So now is about 45 years of the Kerr-Schild geometry and twistors. So Kerr theorem appears in the very famous paper by Debnay, Kerr and Schild of 69. Kerr theorem appears also in twistor algebra paper by Roger Penrose in 67. So recently there were published comments to papers by Kerr-Schild as in series of golden papers, and in these comments there was absolutely comments about the Kerr theorem. So Kerr theorem is described in this paper, as I know before, and it appears before, you see 2 years before this, in the paper by Penrose. There is reference to Kerr theorem too, and formulation of Kerr theorem. But in fact, in this paper, Kerr nowhere called this theorem as theorem. He simply considered it as a very convenient instrument to obtain exact solutions. So really, 2 months ago, I wrote to Roy Kerr and asked him to comment what is the situation with Kerr theorem. He told me, I told to Roger Penrose this Kerr theorem. I told him in 64, where he went to Texas. And sent me this paper. This paper is published in proceedings, in some proceedings. and there is, in fact, formulation of Kerr theorem, but not in final form how it was now in Penrose, but rather in coordinates, in such coordinates, momentum and points. In case of Penrose formulation, it is a couple of spinor coordinates. Spinor coordinates corresponding to momentum, and spinor coordinates which describes disposition of this board line from origin of coordinates. So I will discuss a little bit later. So we will speak about fine structure of the Kerr-Schild geometry based on twistors and twistor beams and black holes along with this paper which was published recently. So let me recall about Kerr-Schild form of the rotating black hole solutions. Kerr-Schild form is extremely simple. You see, it is flat metric plus some contribution, which looks like some perturbation on flat background, but really it is not perturbation, it is exact solutions of the Kerr-Schild form. Function h has such some scalar function, such form, and the most interesting is vector field k mu. This vector field has rather complicated form, and in fact it is clarified while the Kerr-Schild geometry is so complicated in spite of the extremely simple form of the Kerr-Schild metric itself. So situation is related with this vector field k mu. Vector field k mu is determined by this form, differential form, and where y is projective angular coordinate on celestial sphere. Here, this coordinate is so-called null Cartesian coordinates, which is simply related with usual Cartesian coordinates. So Kerr theorem is, in fact, very simple. So it tells that if you have some kind of analytical function of twistor variables, twistor variables are such 1, 2, 3 twistor variables, rather unusual. So you have function of twistor variables. Then solving this equation, you obtain function y from x. That is chain of relations to obtain Kerr solution. So initially you have arbitrarily complex analytical function of twistor variables. Then next step is because twistor variables themselves are combination of Cartesian coordinates and function y. So we have split. This is function of angular variables y and from Cartesian coordinates. And this equation may be solved. It is quadratic equation in y, in function y. It may be solved. We obtain function y of x. You can insert in this expression and obtain French k. So as a result, we have function G mu, we have metric. So this chain of relation shows how in the Kerr-Schild formalism from arbitrary function f, we can obtain the corresponding metric. So it's
as you know, in general relativity, and here the point is that using this Kerr-Schild form of the metric allows you to go forward very fast in a very clear way and get a very deep insight in the physics of the problem. The Boyer-Lindquist coordinates are useful when you compute astrophysical things, but for the typical Kerr-Newman and for
yes, it is more general.
Spatial infinity.
In fact, you have
it is much more general.
Not only this sort of function corresponding to Kerr-Newman,
exactly.
but take any arbitrary function, get another congruency and another solution practically in explicit form.
So, yes. This is not common in astrophysics, but this is the right way to deal with this problem mathematically. Okay, that's simple.
Okay. In fact, it is practically all what I would like to say about. But maybe it is necessary now to look what is the form of this congruency K, which is determine specific structure of the Kerr-Newman solution. And you can see that this form is following. This so-called twistor rays, null rays forms generators of hyperboloids. And there is family of hyperboloids around this singular ring. Singular ring is line of focusing this congruency. So you see very interesting property that if you consider these lines as lines of propagation of some photons, you see that there is some kind of vortex for propagation of photons, and second, that photons are ingoing, going through this ring, and then they are outgoing. So in fact, Kerr-Schild geometry has two sheets. One sheet of ingoing fields, and second sheet is outgoing fields. When we consider exact solution in the Kerr-Schild geometry, for example, solution of Einstein-Maxwell field, then the metric has to be aligned to these lines, and electromagnetic field has to be also aligned to these lines. What it is? In fact, on the same Minkowski space-time, we have two metrics. One of metric is ingoing, we write as K minus, and second one is K plus. So it is two different metrics on the same sheet. So metric is in fact two-sheeted. So this problem of two-sheetedness, because metric on positive sheet is not equal to metric on negative sheet. In fact, you can read in Misner-Thorne-Wheeler that you can use any kind of congruency, ingoing congruency or outgoing. Please, in both cases, you have Kerr solution. It's well, but if you have, for example, electromagnetic field, extra electromagnetic field, which has to be also aligned. So for electromagnetic field, we have to think, do you have retarded or advanced field? Practically, usually we have, in all cases, retarded electromagnetic field. Because of that, you have not such freedom of choice, positive or negative sheet. In fact, we have to use only one version, outgoing congruency. So, two-sheetedness, long time was mystery of the Kerr source. The Kerr ring, in some sense, it may be considered as a mirror gate to Alice world. You're going to via this, obtain negative mass, negative energy, and so on. Meet such problems. So there appears problem of the source of Kerr solution, and sorry, it's typical. Yes. Problem of the source. So one of simplest versions is to consider stringy source. It's started by Newman, then my own works by Israel and so on. So kind of string, the source of the Kerr solution is closed string. But you have to be agree with двушитедность, which is cannot do how interpret this двушитедность. Second version is so-called rotating disk. So first was suggested by Israel, who truncated second sheet. But if you truncated second sheet, you have to replace it by some kind of sources spanned by Kerr disk. So there appears very exotic matter on the Kerr source. And next, Lopez suggested another version. He covered this Kerr singularity by elliptical shell and put it flat spaces inside of this disk. So as a result, he got consistent source in the form of rotating ablated shell and rigidly rotating ablated shell. So it is apparently first consistent model of the Kerr source. And last time there was papers about superconducting back. So this elliptic shell has to be filled by Higgs field. And there is, maybe I have to stop. It is a very interesting topic, really, but it goes in another direction because we speak about source of the Kerr solution in details. So it is very interesting, really, very closely related to astrophysics, because it is, for example, physics of naked astrophysical, without horizon, naked astrophysical sources. So it is very important, but nevertheless we have to move in another direction. Because of that, I will speak about omit this part of talk. But really, there is, I have to say that it is very well modification of Kerr-Schild absatz doing what Gürses and Gürsi. You see Gürses and Gürsi, Gürses and Gürsi retained the Kerr-Schild form, but function h was introduced arbitrary function f at a, f for a. This f at a may be chosen in the form of exact Kerr-Newman solution. It may be chosen, in this case it will be exactly Kerr-Newman solution, but it may be chosen in such form to suppress Kerr singularity. And in fact, this picture shows that we have f at a exactly in the form of Kerr-Newman solution on this line. And then f at a is suppressing the Kerr singularity. What you have in this case, this is exactly Kerr-Newman solution, but this is point of phase transition when we obtain interior de Sitter metric. So in de Sitter interior and external Kerr-Newman solution, they are matched smoothly. And there are another versions you can take like Lopez flat interior and then matching to Kerr-Newman solution. And you can use also anti-de Sitter interior, which will be matched with external solution. So there is Gürses and Gürsi ansatz allows to consider broad class of solutions which describe interior of the external field is exactly Kerr-Newman, but interior will be de Sitter, anti-de Sitter, or flat. So many versions. And this was the common work with Sergei, with Elizalde and Mali. This paper will be renewed recently, soon. So it is convenient form because sorry, there is just the same graphic, that's just the same plot, but its same plot shows that there may be put some line of horizon. Line of horizon is not good seen, but intersection of this line of horizon gives us position of horizons on this plot and position of point of phase transition. Point of phase transition usually between two horizons, internal and external horizons. Okay. So I omit this, and okay. So one more interpretation, the holographic interpretation. When we have two sheets, positive sheet ingoing and outgoing, we can split usual Penrose diagram and obtain splitted hologram which has holographic interpretation. So I will not speak about that more. So let's go to twistor-beams. Algorithm which I discussed before allows it to Debnay Kerr-Schild, in 69, obtain in the form of Kerr-Schild solutions of Einstein-Maxwell equation. Form of metric is such, and tetrad component of electric field is such, and very coefficients, complex coefficients has such form. And it is some complicated functions but I would like only to mention that his function gamma, which in solution, exact solution, expected solution, were not obtained for full this point, only for the case of gamma equal to 0 in this paper, the Kerr-Schild. This case of gamma equal to 0 corresponds to stationary solutions. So because of that, nevertheless, there is still a broad class of solutions. In fact, among this broad class, the Kerr-Newman solution is very exclusive. It corresponds to this function psi equal to constant. What is function psi? This is a Kerr-Schild form of metric, and function h may be expressed in such form that you see function psi is here. So this function psi is in Kerr-Newman solution. It is constant equal to charge. So all is okay, all is smooth here. It is a very, very nice form of Kerr-Newman solution. But Kerr-Newman solution is exclusive because in the general solution obtained by the Kerr-Schild, function of psi may be arbitrary analytical function. And nobody analyzed what will be if you take not constant but any other analytical function. In fact, we can consider the simplest case some kind of polis. What is known? If you have what is function y is a complex function on celestial sphere. So, in fact, a complex function on sphere have to have at least one pole. If it is not constant. Of course, there is constant. If it is not constant, it has to at least one pole. But what happens if you have pole here? If you have pole in function a, then psi has pole. You see that pole is going here in function h. So this pole is produced very strong reaction on metric. In fact, this form determined horizon. It is seen. It was checked in the common paper with Sergey, Elizalde, and Mali that such pole forms beams going from black hole, and these beams pierces the horizon. It forms hole in horizon. So you see, in principle, there you can choose a function with a lot of pole in different angular directions, and as a result, there will be many holes in horizon. So there is exact solution of the obtained by the Kerr-Schild 40 years ago, which contain many holes in horizon. So we have to consider how act such beams on the BH horizon. It is a paper by Elizalde, Hildebrand, Mali, his ref published, and beams lead to formation of the holes in the black hole horizon. In fact, one can see that interior of black hole turns out to be open, and there is no problem of loss information. In fact, it is just the same region. You can look at this picture. Left side of this plot is exact position of horizons for the Kerr-Newman solution closer to extreme value of parameters, E approximately equal to M. So you see that there is a line of ergosphere, there is internal line of ergosphere, this is external line of ergosphere, this is singular ring, and this is two lines of null lines of horizon, very close to each other. However, right side shows that there appears a beam. And this beam penetrates the horizon. You see in which form it happens. Two horizons forms a simply connected surface. Two different horizons forms one simply connected surface. And so such occurs this changing of topology of horizon. And finally, we can look what happens with such which touch horizon. There appears a lot of holes in horizon, and twistor beams are exact stationary time-dependent Kerr solution of type D, which shows that elementary electromagnetic excitation have generally form of singular beams supported by twisternal lines. Interaction of a black hole with external, even very weak electromagnetic field results in appearance of the beams which have very strong back reaction to metric and horizon and form a fine-grained structure of the horizon pierced by fluctuating microholes. So there is references, and the problem is that it is stationary solutions, and the problem was how to obtain this result for non-stationary solutions, for not beams, which is infinitely long, for beam-like pulses, which going, so it is have finite extension, going. So there is rather long work about obtaining such solution. This is full form of, this is equation obtained by the Kerr-Schild, and this is electromagnetic coupler equations, and this is equation of gravitation vector you see here. So it is a very complicated system. It was not really before analyzed by the Kerr-Schild, only for the case of gamma equal to 0, which this system reduces very strongly. And so the problem was to obtain exact solution. So I will not discuss it in details because it is went very far from this lecture. Okay. So in fact, what happens? I would like to only to mention what happens here. There appears extra function gamma, which was absent before. You see that function psi, which we have considered before, with polis, is included here, function psi, but there is some extra homogeneous solutions, and the situation is such that polis of this term may be cancelled by choice of these homogeneous solutions. So there appears some kind of self-regularization of polis. As a result, this function gamma turns out to be regularized and described usual regular field, regular radiation. Therefore, regular radiation, which is very similar to very well-known solution for Vajda shining star. So we obtain such self-regularization. I described how to do self-regularization, and I close it to finish. Now for exact time dependent, we obtain exact time dependent solution for Maxwell equation on the Kerr-Schild background, which produces singular twistor beam pulses. Exact back reaction of the beams to metric and horizon is very strong and go to fluctuating metric and fluctuating horizon perforated by twistor beam pulses. Exact time-dependent solutions for the Maxwell equations on the Kerr-Schild background leading to regular but fluctuating radiation. This is average stress temperature is regular. But nevertheless, the metric and horizon are covered by fluctuating singular twistor beams. Solutions are consistent with averages and equation. What it yields? It yields some kind of semi-classical geometry of fluctuating twistor beams, which takes an intermediate position between classical and quantum gravity. So I finish on this point.
We have time for several questions.
I have a question about these holes in the horizon. Do you think the black hole may lose mass through these holes?
Yeah, in fact, we show this semi-classical geometry which produces many holes in the horizon. As a result, it's some effect which if you average this effect, though you see usual horizon. But really, this we obtain some fine structure of the horizon, and it is a semi-classical explanation of Hawking radiation, in fact. So we have some kind of fluctuating horizon, which in fact exterior of the black hole is not absolutely isolated from interior, so there is possibility to escape. And moreover, the function gamma is classical radiation, which is which maybe radiate just in the necessary form from inside of the black hole.
But it may happen that if the mass goes through the holes, the black hole evaporate.
Yeah.
The question that Arturo has made, I would also like to comment it. Do you have the expression? Maybe some people know by the solution, but do you have the expression here of the loss of mass in the solution?
No, unfortunately not. Unfortunately not. Okay. I think it is impossible to get on classical level. So on classical level you have only a general picture, but you have to some find of how to introduce Planck constant. In fact, you have to quantize it. This is semi-classical. This is spectrum of mass, and mass of black holes is continuous. But to quantize it, of course, there is ideas about how to move forward, because, of course, you have to consider this holographic interpretation. There is incoming radiation, there is outgoing radiation, and there is some kind of brain which divide incoming from outgoing. And this brain has superconducting nature. This boundary of this brain is closed ring, approximately. So it is closed ring plays the role of string, and excitation of this string allows to quantize these excitations, and it is way how to move to get further and further.
I just wanted to stress that if you integrate over a sphere far away from the source, then you can realize how these solutions are representing a compact object which is in the center, and it's transferring energy to infinity. If you were asking.
So in fact, the problem, there is no problem of loss of information inside black holes.
Any other questions? Okay, I do have one. So, given that there's this transfer of energy, could we detect these kind of black holes with holes in their horizon?
Practically, experimentally.
Yes.
No, I think that a very thin effect. It is effect on the boundary between classical and quantum gravity. Because what we experimentally observe, usually it is classical effect, strongly averaged. So it is, in my opinion, it is more closer to problems of quantum gravity. But if we have some kind of, there are such results that we have really obtained superconducting source of Kerr solution, then it may allow us to make some prediction, because what we know, I have shown there that there is some kind of phase transition, external Kerr-Newman field, and some kind of source. But there is phase transition between exterior and interior, and this phase transition is provided by what is usually provided the domain-well model. Domain-well model is related with Higgs field. So you have to, in fact, in this problem of the Kerr source, we need necessity to introduce some kind of domain wall between exterior and interior. And this domain wall can shed the light. It may be experimentally tested, because it is some surface of our astrophysical object which has very definite structure of domain wall, and how it will be interact with particles falling, how it will be emit, and so on. It may be testable. So it is an interesting point.
Any other questions or comments? If not, I do have another question. What role would the magnetic fields play in this kind of solution, or you haven't? Magnetic fields in this solution, would they affect how the holes appear in the horizon, or you haven't gone into detail?
In full, what we have is electromagnetic excitation. So it is electromagnetic beams. But magnetic field plays important role in formation of the source. Because if the source is superconducting, it put out magnetic field and put out currents on the boundary. So
just let me comment. This talk is due to this last development, which has to do with black holes, so to say. You know, we have Kerr-Newman black holes. Then the hydrogens can be pierced by these beams, and you can compute the integral at infinity. You can see that the energy can be taken away or even put inside. No? But there is another line of research that we have been doing for the last years that we have. Well, he has just talked for a minute, and this is the fact that. Does anyone care about what happened inside the black hole? I mean, is there a singularity or is there a regular source? And in case, is there a regular source of a quantum source origin? In the case that these hydrogens are naked, what would we detect in astrophysics? For instance, in the case of a Schwarzschild black hole, the hydrogen is always present. But in the case of a rotating black hole, if it spins fast enough, then the hydrogens open and appears a naked singularity. Penrose wrote an hypothesis for these objects not to exist, because then we would see a naked singularity. But in our joint work, we have also worked in the direction of finding the exact solutions for the sources of these naked singularities, which are simply, was what he's saying, Higgs models of the time. And there could be, in principle, made some predictions for astrophysics. It would be like a neutron star, but of a size of a proton, for instance, something like that.
Yes, because up to my knowledge, models of neutron stars is some kind of handworked. So it is some not exact solution, but it is some kind of combination of ideas how it can be how it is interior of neutron star. But if you have exact solution for electromagnetic source of the Kerr solution, exact solution, it can, of course, it is necessary to compare it with the result obtained for neutron stars and to make some consequences.
If there are no more comments or questions, then I think we should thank again Professor Burinskii.